So let's continue with the importance of involving users. In chapter one, what is interaction design? Stress the importance of understanding people and their activities when designing interactive products. This involves considering users or potential users in the design process, not just to understand them and their activities, but also to test and evaluate candidate designs in their context. Both aspects are necessary because it is the best way to ensure that the end product is usable and provides a good experience so that it will be used. So you don't just study the people, but also their activities when interacting with the products. So these are basically studying the users' interaction with the product. In commercial projects, a role called the product owner is common. The product owner's job is to filter user and customer input to the development cycle and to prioritize requirements for features. This person is usually someone with business and technical knowledge and is often called upon to assess designs. Although they have close engagement with the product and customer needs, they are only able to represent a limited view of the product's use and cannot predict how customer will respond to a given design at any useful level of detail. Two other aspects are equally important if the product is to be usable and used: expectation management and ownership. So there is a product owner that often have not just the technical skill but the business acumen that is better aligned to create the product. Unfortunately, that's not enough. So two other aspects are equally important. Expectation management is the process of making sure that expectations of the new product are realistic. Its purpose is to ensure that there are no surprises when the product is released. If people feel the product has been misrepresented, then this will cause resistance and even rejection. Although avoiding disappointment in design may be particularly difficult to achieve with a large and complex system. So basically, the purpose of this is that to make sure that the product says who, what it is. It should be the same as what you've provided uh, in the design. So it should come like the one you put in design. Second, they will also understand better how it will support their activities, how it will affect their jobs and lives, and why the features are designed that way. Adequate and timely training isn't another technique for managing expectations. Having the chance to see pre-release video or work with a hands-on prototype or early version will create a better understanding of what to expect when the final product is available. A feeling of ownership is another reason for involving potential users. Those who are involved, so let's back up a little bit about this. Basically, you want to provide modules and pre-release videos that explain your product. That way, you manage the customer expectation on what you actually mean by your product. A feeling of ownership is another reason for involving potential users. Those who are involved and feel that they have contributed to a product's development are more likely to feel a sense of ownership toward it and support its use, based in 2017. When developing tools to support Wikipedia contributors, Angelica and Carl Nielsen found that early involvement of members of the Wikipedia community led to a higher acceptance of their innovations. The kind of product being developed, the kind of user involvement possible, the activities in which they are involved, and the application domain will have an impact on the effectiveness of user input, uh, shows in 2015. Peter Richard, 2014, investigated the effect of user involvement in transport design projects. They found that involving users at later stages of development mainly resulted in suggestion for service improvement, whereas users involved at early stages of innovation suggested more creative ideas. So the early stage provide an early feedback that allows you to see what other available options on the design. So the product owner could use these two tactics to enhance its design process. They identified three main consequences of involving older people, learning about older people's lives, adjusting design based on older people's input, and increased sense of participation and feelings of ownership. But their findings also highlight that the empirical papers they surveyed were unclear on the impact that involving users had on acceptance and adoption. Involving people as participants at different stages of the process is without a doubt beneficial, but the key is knowing who, when, where, and how. So they identify that there are three consequences of involving older people. Learning about older people's life, adjusting design based on older people, input and increased sense of participation. They highlight that it's unclear the impact of involving users on acceptance and adoption. Involving people as participants at different stages of the process is without a doubt beneficial, but the key is knowing who, when, where, and how. So it's not just about identifying the people, but also knowing who, when, where, and how. Uh, so it's about knowing uh, when, where, and how, and who uh, at the right time as well. Degrees of user involvement. Different degrees of user involvement are possible, ranging from fully engaged throughout all iterations of the development process to targeted participation in specific activities, and from small groups of individual users in face-to-face context to hundreds of thousands of people online. Occasionally, individuals may be co-opted onto the design team so that they are major contributors to the development. So there are also different ways on how you would involve the user. from fully engaged or to targeted activities during the iteration. On the downside, full-time involvement may mean that they become out of touch with their own community and context of use, while part-time involvement may result in a high workload for them, where user involvement is limited. There are techniques to keep users' concerns uppermost in designers' developers' mind, such as through personas. So you don't there's a lot of way to involve a user, not just to create a workable software. You can also use persona. So user participation may take the form of small groups or individuals taking part in face-to-face information gathering design or evaluation sessions, but increasingly online sessions are used, leading to many thousands of potential users being able to contribute to product development. There is still a place for face-to-face user involvement and in situ studies, but there is now a wider range of possibilities than in the past. So it could be a small group or individuals taking in face-to-face information gathering design or evaluation sessions. So you can also involve the user via online, not just face-to-face. In fact, design is becoming increasingly participative through crowdsourcing design ideas. And examples, for instance, where crowdsourcing is used, a range of different people are encouraged to contribute. This wide participation helps to bring different perspectives to the process, which enhances the design itself, produces more satisfaction with the final product, and engenders a sense of ownership. Another example of involving users at scale is citizen engagement, the goal of which is to engage a population with the aim of promoting empowerment through technology. Once product has been released, a different kind of user involvement is possible, one that captures user feedback based on day-to-day use of the product. This can be achieved in several ways, including collecting and analyzing data that tracks user behavior and analyzing customer reviews and error reporting system. Customer reviews significantly affect the popularity and success of a product based on 2012 research and provide useful and far-reaching user feedback. App reviews are particularly plentiful in this regard, but analyzing them can be time-consuming. Mining app reviews for conflict improvements and organizing information efficiently is being widely researched, and several approaches use machine learning techniques. So once the product has been released, the way to involve the user is a day-to-day use feedback and using analytics tool to measure their interaction with our system. For example, Maram suggests a neutral network-based approach to identifying high-level features from reviews, while Korean Gao 2019 applied topic modeling to reviews posted on WeChat. Twitter has also been suggested as a good source of app reviews. Error reporting systems. So basically, a network-based approach to identifying high-level features could also get from these analytics tools. And sometimes you can also get data from WeChat or Twitter. For error reporting systems, ERs, also called online crashing analysis, automatically collect information from users that is used to improve application in the longer term. This is done with user permission but with a minimal reporting burden. Figure shows two dialog boxes for Windows, error reporting system that is built into Microsoft operating system. This kind of reporting can have a significant effect on the quality of applications. For example, 29% of the errors fixed by Windows XP Service Pack 1 team were based on information collected through their ERs. While Windows XP is no longer being supported, this static illustrates the impact ERs can have. The system uses a sophisticated approach to error reporting based on five strategies: automatic aggregation of error reports, progressive data collection, so that data collected such as abbreviated or full stack and memory dumps varies depending on the level of data needed to diagnose the error. Minimal user interaction, preserving user privacy and providing solutions directly to users where possible. So these are the principles. You aggregate the report, you only get the data that you need. It varies depending on the kind of data uh, collected, such as memory dumps or full stack. And minimal, it has minimal user interaction, and then it preserves user privacy and provides solution immediately. By using these strategies plus analysis, efforts can be focused on the bugs that have the highest impact on most users. So basically, by doing this after your product, you are able to analyze or prioritize the errors that has the highest impact to your users. So what is a people-centered approach? Several decades ago, when the field of human-computer interaction was being established, John Gould and Clayton Lewis, 1985, laid down three principles that they believed would lead to a useful and easy-to-use computer system. These principles are as follows. So these are the principles of people-centered approach. Early focus on users and tasks. This means first understanding who the users will be by directly studying their cognitive, behavioral, anthropomorphic, and attitudinal characteristics. This requires observing users doing the normal tasks, studying the nature of those tasks, and then involving users in the design process. So you focus on users and the tasks that they are doing by observing it, the normal task or most useful task, studying the nature of those tasks, and then involving users in the design process. So you study how those tasks interact with um, with your system, and then you involve them in the process. Empirical measurement, early in the development, the reactions and performance of intended users to printed scenarios, manuals, and so forth are observed and measured. Later, users interact with simulations and prototypes, and their performance and reactions are observed, recorded, and analyzed. Iterative design, when problems are found in user testing, they are fixed, and then more tests and observations are carried out to see the effects of the fixes. This means that design and development are iterative, with cycles of design, test, measure, redesign being repeated as often as necessary. These three principles are generally accepted as the basis for a user-centered approach, but when they were first presented, they were not widely applied or understood. In people-centered approach, this principle form the basis for designing with people, communities, and other stakeholders, and are expanded through the following further principles. People's task. So this is the continuation. So uh, here we focus on user and task, and then measurement, and then iterative design. Now we add here two bullets. People, tasks, and goals are the driving force behind the development. While technology will inform the design options and choices, it is not the driving force. Instead of looking at how the new technology can be deployed, ask what technologies are available to provide better support for people's goals. So instead of thinking of new technology that can be deployed, what technologies are available to better support people's goals, because ultimately you're dealing with people's problem. You're using technology to solve people's problem. People's behavior and context of use are studied, and the system is designed to support them. This is not just about capturing people's tasks and goals. How people perform their task is also significant. Understanding behavior highlights priorities, preferences, and implicit intentions. So you also analyze the behavior of people in the context in which they use it, and is the system are designed to support it. So the like in the cognitive, uh, in the attention topic, basically you're trying to improve the salient information in which people navigate. This is not just about capturing people's tasks and goals. How people perform their tasks is also significant. Understanding behavior highlights priorities, preferences, and implicit intentions. So this will dictate the priorities uh, uh, of your environment to accomplish the task. People's characteristics are captured and designed for. When things go wrong with technology, people often think it is their fault. People are prone to making errors and have certain limitations, both cognitive and physical. Products designed to support people take these limitations into account are designed to prevent mistakes from being made. So people are prone to error, so the products that helps them do their task is ultimately what will win, even though the other product has more features because it's not easy to use. So it's prone to human error, then it will not be used because it is like a command line based language that is not intuitive for people. It puts a lot of cognitive load. Cognitive aspects such as attention, memory, and perception issues are introduced in Chapter 4, Cognitive Aspects. Physical aspects include height, mobility, and strength. Some characteristics are general, such as color blindness, which affects about 4.5% of the population. But some characteristics are also associated with a particular job or task. In addition to general characteristics, those traits specific to potential user groups are relevant. So different people have different capabilities. Some could understand a system faster. Some could understand emotion faster. So basically, you have to design your product based on the target demographics. So there. So you try to get their characteristics. Here, basically, you don't get the characteristic. You just measure. You focus on user and task, but you don't focus on the individual psychology. What makes us different, right? Some can't even read because they have ADHD, right? They have a heart injury. Some are blind. You can even see. Some are some couldn't hear. So those are capabilities, unfortunately, that was not provided to them. Some are also not socially aware. They don't know how they look socially, so they have a hard time getting along with people. So to remedy that, you need to be able to read classic books, but preferably you want to do that before your age 28. Users and other stakeholders are consulted throughout development from earliest phases to the latest. As discussed earlier, there are different levels of user involvement, and there are different ways which to consult users. Another thing with people is that a lot of times they don't know how they did a thing. They are just affected by their environment. So a lot of times it's not really about how good you are. It's about a lot of things of your capabilities depends on your environment. Users and other stakeholders are consulted throughout development from earliest phases to the latest. As discussed earlier, there are different levels of user involvement and there are different ways in which to consult users. So users and not just users, all the stakeholders. Later we will discuss. Yeah, stakeholders are the people that affected directly and indirectly by your product. So you will there are different level of user involvement, how much they were involved, and there are different ways in which to consult users. And then fifth, all design decisions are taken with the context of use, people's activities, and their environment. This may mean that users are actively involved in design decisions and co-creations is one approach to this. So it's an iterative process. You're not just considering one system. So you're trying to kind of like system-based design approach. You're not just deciding based on people different characteristics. You're also designing based on their environment, based on their previous knowledge, based on what we need at that time. So you're trying to consider a lot of different things at once. So that requires what we discussed in the previous cognitive frameworks, problem solving, planning, etc. So those are higher level cognitive thinking. So the reason as well you want a feedback early and you want other people to give you feedback is to know what is the thing that you the the thing that how could you improve, right? It's all for you to be better. Assume you are involved in developing a novel online experience for buying garden plants. Although many websites exist for buying plants online, you want to produce a distinct experience to increase the organization market share. Suggest ways of applying these five principles in this task. So here's a way for us to apply this. To address these first three principles, we would need to find out about the types of consumers, behavior and characteristics of potential consumers of new experiences, together with any different contexts. The use of existing plant shots will provide some information and it will also identify some challenges to be addressed in the experience. As you want to increase the organization's market share, consulting existing users alone would not be enough. Physical shopping situations, for example, shopping at the market, in the local corner shop, and so on. Forecast. These alternatives will help to find the advantages and disadvantages of buying plants and will inform behaviors. By looking at these options, a new set of potential users and contexts can be identified. So here's by in the market, you were able to find different contexts that you would apply on your system. Maybe you can use the old system features, or you can use the present feature, or and then add remove some feature, or you can use feature and then remove some feature. So it really depends on the data collection or the data that so you will uncover different behaviors doing that. You're able to see advantage and disadvantages. And then depending on that, how you will apply that to your specific goals. So for sometimes information, so maybe you don't need to collect a lot of information from other people. Maybe you just need to find three the same product. So for the fourth principle, people who are interested in gardening and buying plants online, workshops or evaluation session could be run in various shopping environments such as the market. The last principle would be supported with the creation of a project or war room, a room where the results of user-focused sessions and emerging insights are displayed. The development team can generate design ideas and create prototypes surrounded by information about users context and the product's goal. For the front end side, we will apply this by basically you're trying to involve the user. We could shop for evaluation session that could be run in shopping environment such as the market. And that's flexible but is supported through the creation of a project or war room where the results of user-focused sessions and emerging design are on display. Here the development can generate design ideas and create prototypes surrounded by information about users, their context, the products, goals. So in here, where you're involving the users, you generate ideas and create prototypes that measure feedback, their context, and the product's goals. Four, basic activities of interaction design. Basic activities of interaction design are as follows. Discovering requirements for the interactive product design frameworks that include prototyping the alternative design so that they can be communicated and assessed. Evaluating the product and the user experience discovering requirements. In the case of this involves understanding the target users and the support and interactive use. This understanding is gained through data gathering and analysis, which are discussed in future videos. It works requirements and subsequent design and development. So you start in the end, you collect data, you analyze the data. In this generating requirements, you are the data, and then you start at the end, and then you go back to the start, and then make the and as you go, you change your theory or requirements based on the new information that you get. This is designing is part of the develop phase of the double diamond, proposing ideas for meeting the requirement. This activity can be built as two sub-activities: conceptual design and concrete design. Conceptual design involves and a conceptual model describes an abstraction, outlining what people can get to understand how to interact with it. Concrete design considers the detail of the product, including the colors, figures, menu designs, and icon design. So conceptual design is about the concept of the product. It's the outline of what people can do and what concepts are needed to understand how to interact with it. The concrete design considers the details. So it's the it's not the high level view, but it's the details of the product. The color, sounds, terminology, and images types. Menu design and icon design. So you would think that designing alternatives was all about the detail. No, it has actually a high level concept and concrete design. Prototyping. The most effective way for people to evaluate such designs is to interact with them. And this can be achieved through prototyping. This does not necessarily mean that a piece of software is required. There are different prototypes, not all of which require a working piece of software. For example, paper-based prototypes are quick and cheap to build and are effective for identifying problems in the stage of design. And through role playing. People can get a real sense of what it will be like to interact with the product. So, prototyping, like what I've said before, does not necessarily mean real software, but it could be a written was debated by your team members, quick and cheap to build, or like user personas that represent the early stage uh, role playing. Evaluating is the process of determining the usability and acceptability of the product or design measure in terms of variety of usability and user experience criteria. Validation is quality assurance and testing to make sure that the final product is fit for its intended purpose. But it commonly involves the activities to discover requirements, design alternatives, build prototypes, and evaluate them are intertwined. What is evaluating is process of determining usability and acceptability. So how users accepted the product based on different measurements that you created using your requirements and how the based on knowledge of how the user interact with the system. The activities to discover requirements, design alternatives, build prototypes, and then evaluate them. Alternatives are evaluated through the prototype, and the results are fed back into further design. In this feedback is indicated by dashed line arrows. It is indicated by solid arrows. So basically, in here, the results are fed back into further design or further development. This feedback is indicated by dashed line. So uh, um, here, the dash, develop, and then solid line arrows. So when you deliver, there's a feedback, then you develop it. So it's kind of like a agile methodology which we discussed in the previous videos. And then comes the frameworks for innovation. The double diamond of design at its heart. A simple life cycle model for interaction. A life cycle model or process is used to represent a model that captures a set of activities and how they are related. Existing models of varying levels of sophistication are often not prescriptive. For projects involving only a few experienced developers, simple processes are enough. However, for large systems involving tens or hundreds of developers, a simple process just isn't enough to provide management structure and discipline necessary to engineer a usable product. So, this lifecycle model is used to represent a set of activities in the product and how they are related. So, varying models or representation of a product vary in its complexity. So, representation is maybe simple developers. However, for like a large system, it's hard to get like a representation of how the system actually works having interconnected classes. So A, for example, engineering lifecycle models include the one models models. For more information about this model, see Pressman and Max in 2019. HCI has been less than lifecycle models. Two well-known ones are Starr, Hudson, and Hicks in 1989, and an international standard, ISO 924-210. Rather than explaining the details of these models, we focus on the simple lifecycle model shown here. Design alternatives. Then you discover the requirements, you evaluate, and then you test it via prototypes. You go back to designing alternatives. Many projects start with discovering the requirements, from which alternative designs are generated. Prototype versions of prototypes are developed during prototyping or based on feedback from evaluation that need to refine the requirements or to redesign. So the prototype version are developed evaluated. During prototyping or based on feedback from evaluations, the team may need to refine their requirements or to design. One more, one or more alternative designs the cycle. Implicit in this cycle is that the final product will emerge in an evolutionary fashion from through initial or from limited functionality to sophisticated functionality. So a lot of projects start, or most of the projects start by discovering which designs are generated. So based on these requirements of the user, you like what we have plant metaphor, we check the market, the available solution, and then from there we generate additional feature based on their specific like framework on what is applicable on our process. So prototype versions of the designs are evaluated and then you iterate. During prototyping or based on feedback from evaluations, the team may need to refine their requirements during design. One or more alternative design may follow this iterative cycle in parallel. Implicit in this cycle is that the final product will emerge in an evolutionary fashion from an initial idea through the finished product or from limited functionality to sophisticated functionality. So you start with one alternative design and then you iterate it, you test it. So later on, the cycle is like development. So you don't just create this sophisticated functionality from the start. You start with a simple you test and then test until it becomes sophisticated functionality. So that's another way. In recent years, a wide range of life cycle model has emerged, all of which with activities, relationships, and output. For example, design sprints investigation, solution development, and testing. This does not result in a robust does make sure the solution idea is acceptable to customers. So there has been a lot or it provides or encompass activities with different emphasis on so in design sprints, which is here, it's like an agile methodology. The design sprint is a flexible set of methods to solve problems through an iterative process of designing, prototyping, and rapid reduce the environment. The methodology can be used to support a range of design goals and organizational aims under a shared vision. The design sprint follows six phases, and between one a sprint plan, write a sprint brief, choose the right design challenge, assemble the right team, and organize the time and space for the sprint. So basically, you start with a sprint brief, you choose the right design challenge, assemble the sprint, basically you assemble the team and organize the time and space to run this project. First, articulate the problem space. So you're trying to explain what it is that you are trying to phase one and identify a focus on the sprint. After that, you focus on the most important problem and then generate ideas and solutions. Then work as a team to identify a single well-developed solution per team member. Then each team generated their solution to the problem and then choose the single idea to choose the best idea that is realistic and then you develop a prototype to test that idea for the chosen solution. So it's really not focus only the aspects you want to test. So basically it's a minimum you're trying to get just to get the requirements work. You're not trying to like create this amazing thing, but you're just trying to iterate and test if it works. Gather feedback on the prototype from users and other stakeholders, and then you get users of your system and the stakeholders indirectly affected. At the end of this phase, your chosen solution. The aspect of design sprint is that they are time boxed enough, time to test ideas and keep the energy high, but also not too high that ideas become overwhelmed by detail. This is similar to the idea of sprint used in the agile method. So here phase one, understand the schedule, prototype validate. The approach supports designing prototype in ways because often experiment technological possibilities that can change and even disrupt behavior, rather than ones that fit with existing processes. The results of our RTW studies can be used to challenge assumptions about technology and human behavior HCI theories. The perspective taken by our ITW studies is to observe how people react to technology and how they change and integrate into their everyday lives. So, what if you want to create a or to test a newly invented or unique a new idea? So, take note, there are very few new ideas. So, it's a combination of existing ideas. So this approach is designing and then experimenting possibilities that disrupt the behavior. So instead of aligning with the expected behavior, you try to and see how the behavior of the user respond to the new framework. So this framework focuses on design, prototyping and evaluating technology and ideas, and is one way which requirements may be discovered. It also considers relevant theory, since often the purpose of an RRTW study is to theory, idea, concept, or observation. Any one RITW study may emphasize the of different degree. Okay, so here's an example of that. Some practical issues. So let's move on. Basically, we start with theory and then in studies design and then technology. How to find out what people need. If you have asked someone in the street in the late 1990s what they needed, their answer would probably have included a smartphone, a ski jacket with an integrated smartphone, or a robot pet. If you presented the same person with these experiences and asked them to buy them if they were available, then the answer may have been more positive. Determining what and then supplying it because people don't necessarily know what is possible. So a lot of times, so if people have been asked what they need, they wouldn't say but uh, but if you could if they would buy something, then that's a good side. So like buying or having other people like, is the is the way of what's possible and the limitation of this technology and how they can help them. Susan and James Robertson were needs, which reduce the where they might have. Instead of asking people, this is approached by exploring the problem space, investigating their context and their activities to see what can be improved, or trying out ideas to see what would make in practice. Make sure is often taken, trying ideas in order to discover requirements and decide what to build based on the space, potential users, and other stakeholders and their activities. So basically, this approach starts again on generating as much ideas and then investigates the users, the context, everything related to the system as well as the stakeholders and their activities, and then trying out the idea and see if it would make a difference. So it's like trial and error. You try some ideas that you think may work. So in practice, a mixture of this approach is often taken, trying ideas in order to discover requirements and decide what to make based on the problem, space, potential users, and other stakeholders in their activities. So a lot of times you're not aware of those for example, the activities and this context or this context and these people. So a lot of times you have to try it. Just like university, what you don't know if you don't try to teach it or to verbally explain it. You don't know what you got if you don't articulate it in written words. In the cloud, there's graphic design scripts that provide feedback on early ideas are particularly valuable when the product is in production. Rather than imagining how to use a product and what they might want to do with it, it's more effective to go there and sur- surprising. So it's about trying out these new ideas. Several practitioners when developers or designers see a user struggling to complete a task that seems so clear, focusing on user experience goals is more promising approach to interaction design than simply expecting for a product. How to decide what to design? But it can be overlooked by those new to interaction design. By this we mean focusing on the design action style used. So basically, in this, the problems are that potential users and their context can be misunderstood. Problems with existing product usability and user experience can be overlooked. So because of the problem could be a result of a combination of factors that you may not aware of. So instead of just exploring the relationships with the interaction, such as activities, people, the stakeholders, focusing on the physical interface of the technology to know how to decide what to design. Because this physical interface is already there, and then the interaction was there. But how about a different interface and a different interaction? For example, consider the augmented reality displays and holographic navigation systems that are available in use by users. They are the result of decades of research into human factors information displays. For instance, the driving experience itself. in 2013 and the suitability of different technologies. For example, in 2016, understanding the problem space has been critical in arriving at workable solutions that are safe and an example of immersive holographic display that shows information about the vehicle, infotainment distances, and augmented reality navigation system available in some cars today. Use technology to employ and decide how to design the physical aspects. It is better to make these decisions. By this we mean understanding what is currently the user experience or the product, why a change is needed, and how this change is. So, designing the interface or the end technology is not good when designing a product because you're not exploring all the available choices. You're not exploring the real problem of the customer. So exploring the problem is the first step. This involves finding what is problematic with existing support for navigating while driving. An example is ensuring that drivers continue to drive safely without being distracted when looking at a small GPS display mounted on the dashboard to figure out how an issue is asking them to turn left. Even when designing for new interactive experience, understanding the context in which it is is the key. So it's been 1 hour. Uh, let's just finish this and then let's go. So basically, you find out what's problematic navigating while driving. So that's why you have this augmented because navigation is dangerous while driving. Uh, it ensures that drivers can drive safely without being distracted. When looking at a small GPS display mounted on the which road to check that. Even when designing for a new interactive experience, understanding the context in which it will be used. Space is typically done as a team effort, and team members will have different perspectives. For example, a project manager is likely to be concerned about the proposed solution in terms of budget, timelines, and stopping costs, whereas specific technical concepts. So articulating a problem is not easy as different people define it in different ways. Software engineers think of a technical problem, team members concerned about the timelines and the cost, although time consuming and sometimes disagreements. Among the design team, the benefits of this process can far outweigh the associated costs. There will be much mistakes, incorrect assumptions, and unsupported claims creeping into a design solution that later turns out to be unusable or unwanted. Spending time reflecting about the ideas during the early stages of the design process enables more options and possibilities to be considered. Furthermore, designers are increasingly expected to justify their choice of problems and to be able to present clearly and convincingly their rationale in business as well as design language. Being able to think and analyze, present, and argue is valued as much as the ability to create a product. So basically, designers are increasingly to justify their choice of problem and to present clearly and convincingly their rationale in business as being able to explain, articulate, analyze, and present your ideas is as much valuable as you designers today now have to explain the requirements or the problem that I'm using. So there, guys, we will continue with how to generate alternative designs, how how to find. We discussed like how to design we also discuss, let's see, the life cycle model for interaction design. We discuss evaluate four basic activities of development design. One is user-centered approach, degrees of user involvement, the importance of involving users, how to improve the design process. So yeah, we discussed a lot. And then yeah, we're almost done with this very important or basic topic. Again, guys,